In this video, let's see how to write a simple assembly language program, how to convert that ALP into machine code using opcode sheet, how to enter this machine code in 80 microprocessor kit, and finally how to execute and verify result in 8085 microprocessor kit.
Here we can have a microprocessor kit, namely STS85, with memory range varies from 2000H to 7FFH. So here you can use any memory location in this range except this location. In order to see the basics of how to enter a program into microprocessor kit, let's consider a simple example. Here the problem is load an 8-bit number in C register and transfer that number into location 5550H. So in laboratory you need to follow this format. First of all, you need to write the memory address where you are saving the machine code corresponding to each instruction. So that is this one. So this part indicate machine code corresponding to each instruction. Where you are saving that machine code, that you need to write here. So first of all, let's see the program. Here the problem is load an 8-bit number in C register. So we don't know the number that you can decide. Say I am taking the number as 80. 80 I need to move into C register, then that number I need to transfer into this location. So first of all, we need to use immediate addressing mode, that is MVI C,80H. Whenever this instruction is executed, the data which is directly given in the instruction, that is 80H, that is transferred into C register. There is no direct instruction in order to transfer the content of C register into this memory location. For that we need to move through accumulator. So that number which is available in C register, now we need to move into accumulator by means of this instruction, that is move A, C. Whenever this instruction is executed, whatever be the content of C register, that is transferred into accumulator. Now this number is available in accumulator. We can transfer that number into this location by means of this instruction, that is STA5550H. Whenever this instruction is executed, whatever be the content of accumulator, that is transferred into this memory location 5550H. As our task is over, we can stop the program by means of halt instruction. So this is the assembly language program. This assembly language program is not known to our microprocessor kit.
So we need to convert this assembly language program into machine language program. That is, here we need to find out the machine code of individual instruction with the help of opcode sheet. Let's see how to convert this instruction into machine code.
First of all, we need to fix the memory address. From which memory address onwards you need to save this machine code. So for that, let's choose 2000H itself. So the memory address which I am going to save the opcode corresponding to this program is starting from location 2000H, that you need to write over here. Then what is the opcode corresponding to MVI C, data 8? It is OE. So in 2000 you will save
0E.
Then you need to save 80, that is in 2001 you need to save this data. In order to save this instruction, it requires two consecutive location. So this is a 2-byte instruction. So what is the next address? This is 2000, this is 2001, and next address corresponding to this instruction machine code is 2002. So what is the machine code corresponding to this instruction? Move A, C. It is 79H. This instruction is a 1-byte instruction. So in next location you need to save the machine code corresponding to this instruction, that is the memory location is 2003. What is the opcode corresponding to STA 16-bit address? It is 32. After 32H you need to enter LSB address, that is 50. Then you need to enter 55. In order to save the machine code of this instruction, it requires 3 consecutive location. Therefore this is a 3-byte instruction. So in 2003 we will save 32. That is the opcode corresponding to this one. Next, 2004 we will save LSB address. 2005 we will save MSB address. Next location is 2003, 4, 5, 6. Corresponding to halt, the machine code is 76. So in this way, you need to write memory address and machine code. Label and comment is optional. It is only for good documentation. If this is not available, nothing to worry. Label is not a part of program. You can write say start over here. It is just for understanding in order to increase the understanding level. Here also if needed you can use stop.
Here, while writing ALP, it is to be noted that label and mnemonics can be separated by colon. A semicolon is used before writing comments.
So this is our 8085 microprocessor kit STS85. When we are switching on this one, you can see that one. So you can see here the display is STS85. Here this portion is corresponding to memory address and this portion is corresponding to data. Now let's enter the program which we written earlier. So the first address is 2000. 2000H we need to enter 0E. Then next 80, 79, 32, 50, 55 and 76. And after that we need to execute the program. Let's see how to enter these machine codes into this microprocessor kit in detail. So first one is here you can see one key namely reset. This is reset button. So first you need to enter reset button. Then you can see one key namely emem that you need to enter. Then you can see nothing is available there. Now you can enter the memory address 2000H. Then you need to enter next. Here you can see one default data which is available in 2000 that you need to replace by 0E. Again enter next. Now you can see the memory address is increased to 2001. In that location you need to enter 80. Again next. In location 2002 you need to enter 79. Then you need to enter again next. Now the address is 2003. Into that location you need to enter the machine code corresponding to STA5550. That is firstly 32. Again next 50. Again next 55. Now after next you can see 2006 is the last memory address corresponding to halt. For halt the machine code is 76. Next, then only that 76 will save into RAM. Next, let's see how to execute this program by means of this processor kit. For that one you need to follow this sequence. First of all you need to enter reset. Then you need to enter go. Then starting address, that starting address here is 2000. Then there is a key namely fill. You can see a display over here that is E. E stands for execute. If there is an error, it won't show this E. Now the display is showing E, that indicate that there is no problem for our execution. Now we can see whether our data is reached into the memory location 5550 or not. For that again you need to enter reset emem. Then you need to enter the location 5550. Next you can see that the data which I entered in C register is reached into 5550H. In this way we can check whether the data is reached into particular location or not. Now let's see how to execute this in single step manner. For that one you need to follow this sequence. First of all you need to enter reset button. Then single step button is there just below that one. Then you need to enter the starting address. Starting address is 2000. Then you need to enter next. So after again one next, the previous instruction is get executed. After this next, the memory location 2002 points the opcode corresponding to the second instruction. That means previous instruction is executed. Now let's check whether the data 80 is reached into C register by means of the previous instruction execution or not. For that one you need to enter fill. Then you need to enter shift button. Then you need to enter register button. You need to enter the required register, that is C register. You can see that C register content is now 80H. That is the data which is directly given in the instruction is reached into C register. Now we need to again go back into the memory location 2002. For that one you need to enter fill, then shift, register. You can see it is pointing the opcode corresponding to second instruction. Now we need to execute second instruction. For that one, you need to enter again next. Now let's check whether that C content is reached into accumulator or not by means of previous method. For that one, you need to fill, then shift, register. Then you need to enter A register. Here you can see that A register content is 80. That was the content of C register. That means C register content is now reached into accumulator. In order to come back into memory address 2003, we need to again enter fill, shift and register. It is reached into 2003. In order to execute STA5550H instruction, you need to enter again next, so that it will point the last address corresponding to the instruction halt. Now if needed, we can check all the registers which is available in 8085 microprocessor by means of the previous method, that is fill, shift, register. Now let's start from A register onwards. A content is 80. Next B content is FF. Next, when we are entering next, it will automatically increment each registers which is available in 8085 microprocessor. Now C register content is 80. Next, D register content is 00, that is the default value. E register content is 6A. Next, F register content is 44. H register content is 27. Next, L register content is FB. Then content of PCH. What is the need of program counter? Program counter contains the address of next instruction to be executed. Now PCH content is 20, that is the MSB address. Next, PCL content is
06.
So PC is now pointing the location 2006. Now SPH, stack pointer, default stack pointer contains the address of stack top. So SPH is pointing 27. Next, SPL is pointing 64. So in this way you can check all the registers which is available in 8085 microprocessor. Now again we need to go back into memory address. For that one you need to enter fill, shift and register. In this way you can execute single step execution. In earlier method you can execute full programs.